The topic is continuous functions of two variables. So let's do the first example. Determine all points at which f of xy equals square root of 9 minus x squared minus y squared is continuous. Alright, so let's read the definition. The definition says polynomial rational functions, radical functions, logarithmic, exponential, and trigonometric functions are all called elementary functions. What do we know about those elementary functions? We know that elementary functions are continuous on their domain. Not only that, we know that the composite functions of elementary functions are continuous on their domain. Alright, this is still just a radical function, so we know it's continuous on its domain. So therefore, all we need to do is find the domain. What is the domain of f? Domain is the set of all xy's such that whatever under the radical has to be bigger or equal than 0. What does that mean? That means that minus x squared minus y squared is bigger or equal than negative 9. Alright, I'm doing subtraction 9 from both sides. Divide by negative 1, you get x squared plus y squared is less or equal than 3. So basically, what is the domain is the disk x squared plus y squared less or equal than 3. So let's draw our disk. So I have 3, negative 3, 3, negative 3, oops, 3 squared, actually 9. So it's a disk, the radius is 3. So this is our domain. Right? Now, for question B, is f continuous at all points in the region x is between negative 1 and y is between negative 1 and 1. So we can use the same, so negative 1 here, 1 is right there, and then 1, y is between negative 1 and 1. So we're talking about this region. Oops, this is negative 1. So is it continuous there? Yes. This rectangular region or that square is inside the disk. So at each point on the disk it's going to be continuous. The region is a subset of our domain. So the answer will be yes, because our region, let's call it R, is a subset of the domain. Now let's do problem C. Is f continuous at all points in the region x is between negative 4, y between negative 4 and 4? Let's do another one here. So negative 4, 4, this is 4, negative 4, so this is our region. We want to know if it's continuous there. Now what do we know? We know it's continuous on this disk. Negative 3, negative 3, 3, 3. So of course it's not continuous on our region, because if we pick this point, and let's call this, let's pick a point that we know it's in there. For example, 3.5, oops, 3.5, 3.5. So we know f is not continuous there. F is not continuous at the point 3.5, 3.5. Therefore, f is not continuous on our region R. Let's call this region R. Right? To show that a function is not continuous on a region, all you need to do is show that it's not continuous at a point in that region. Alright, so let's do the next example. Question A, determine all points at which f of xy equal x squared y over x squared plus y squared is continuous. So how do we do that? Again, this is a rational function. If you look at the definition, a rational function is continuous on its domain. So let's find the domain. The domain is the set of all xy such that f of xy is defined. Rational function is defined at all points where the denominator is not equal to 0. So what does it mean x squared plus y squared is not equal to 0? It just means x is not equal to 0 and y is not equal to 0. In other words, xy is not equal 0, 0. So the domain will be all the points, the whole xy plane, and then excluding the point 0, 0. So it will be everything except that point. Alright, now for question B, is f continuous at all points in the region x is between square root of 2, square root of 5? Let me do another one here. Square root of 2, square root of 5, and then the y is between 1 and 3. So we're talking this region. We know the function is not continuous at this point, so it's okay. So the answer will be yes, f is continuous on the region R. So let's call our region R to make it easy. Now for question C, is f continuous at all points in the disk x squared plus y squared that's equal to 9? So yeah, let me do it here. So here's the point 0, 0. So if you pick the disk x squared plus y squared less or equal than 9, the radius is 3. So 3 minus 3, 3 minus 3. So the answer will be no, f is not continuous at all points in the disk x squared plus y squared less or equal than 9. Why? Because all I need to show one point in the disk where it's not continuous, and of course I'm going to pick 0, 0 because 0, 0 belong to the disk, but f is not continuous at 0, 0. And that's it for this example.